Hello and welcome to this episode of Science at Home. My name is Jeff Payne. I'm an analytical chemist at the 3M company and I work in our corporate analytical lab. And I have a really fun job because we get to look at literally something maybe that was invented yesterday by a researcher at 3M, or maybe a product that's been around for 30, 40 years we get to look at. So it's been tons of fun. I've been at 3M for 33 years and I've been doing the same job for all 33 years because it's been very exciting and fun for me. I'm also the chair of the 3M Visiting Wizard program, where we take science out into the community and the schools and show our love for it. And to say that we're disappointed that we can't do that right now is a huge understatement, but welcome to my living room. We're going to do an experiment in my living room today, and it's called liquid fireworks. Now, doing fireworks inside the house, probably not a good idea. So as you can tell, it's probably just a neat little title of a different experiment. So what do you think? Should we get started? What we're going to do is we're going to use some milk, a plate to put that milk in, and then we got some food coloring and a little bit of dishwasher or dish soap, and then some cotton swabs. And so how this is going to work, let me get all my pieces in a little bit better manner here. But I'm going to use these glass pie plates, and so we're just going to take a little of the milk, and I'm actually using whole milk here. And as you probably know, there's different kinds of milk in the store that you can pick up, which is really kind of nice because that actually gives us some variables now when we do experiments. And when we say we're going to use a variable, it's basically something that we're going to change. And so you could go with the whole milk like I'm using today. You can maybe use 2%, 1% skim. Do any of these make a difference? Maybe even go to something like heavy whipping cream and see if we get a little bit of a difference. But anyway, we're going to put some water in the dish. Enough to cover, maybe a little bit different. And again, that could be maybe a variable, as if you want to try this at home, is what happens if you make the milk shallower or deeper? Does that make a difference in what happens? So we're going to take a few drops of our food coloring, put them in a kind of towards the center here on the first go around. And there's a little bit of yellow, there's a little bit of blue. The blue is always interesting because it likes to float all over. Let's put another couple of yellow in there just to see what happens if we spread it out a little bit. A little bit of green. And a little bit of red. All right, so they kind of are trying to diffuse around just a little bit there, you can see. But the trick to this is now we're going to go to our dish soap. We're going to get some on the end of the cotton swab, and then you want to kind of wring it off a little bit on the edge. You want to have some on there, but you don't want to have it to the point where it's going to be dripping off. And then all we have to do is, in this case here, we're going to bring our cotton swab right into the middle of where we put our food coloring, and we're going to watch to see what happens. And all of a sudden, see why we're calling it a liquid firework? Now all of a sudden we have colors shooting all over in different directions. So now the question becomes, why would something like that happen? I think first thing we have to do is we have to go back and think about milk to begin with. Milk has got a lot of water in it, but yet it's white, we can't see through it. And the reason why we can't see through it is it has some things dissolved in it, some of which are fats, and fat doesn't really like water very well. And so what happens is we end up with these little globs of fat floating around in there, and so when light hits our milk, it scatters off of those because it can't go directly through. It gets scattered back. Since our light is actually white, has all the colors in it, it gets scattered back and it looks white. Now, oil and water don't like each other particularly well. That's why we get these little particles. But what the magic of the soap is a long molecule that has one end likes fats and oils and greases and things like that. The other end likes water. And so it helps make those two things mix together. And so then we can use that in case, in terms of cleaning our hands, or if we're trying to wash our clothes, it actually is able to kind of move that grease off of the whatever we're cleaning and get it to get up into the water, and then moves away in with the water and out of our clothes. Now the interesting thing about this thing is we can actually kind of put our swab back in a couple of spots, and you'll notice that again we get this running as again now that soap diffuses out, which means it goes from high concentration to low concentration, and as it does that, it's kind of grabbing up some of those fat particles that are in there, letting them get into the water, and looks like we see things moving. And the food coloring is really just there for us to actually see that. If we put the swab in, the milk would still move like we see, but we wouldn't be able to have any indication that is actually happening. Now the other thing, fun thing about this experiment is you can do a second one now. We have our colors all over, and now if you kind of gently agitate the pan a little bit, now these colors start to mix a little bit more, and you get some other fun shapes. Sometimes if there's still a little soap at the bottom, sometimes all of a sudden you might see some things pop up, again kind of looking like fireworks coming up from the bottom as it's mixing, as we move some of that stuff around a little bit, and we get to see that happen again. So kind of a fun thing, and the fact that soap helps helps the fat and the water mix together. Let's do it again. First one was so fun, let's do it again. So what we're going to do now, I've got a second plate here. Put a little bit of our milk in. And this time I'm going to make a couple of spots. I'm going to make one there. Green. And red on this side. And then I'm going to put a little bit of gap. I dropped my blue one, so I got to grab my blue one off the floor. So I'm going to put a little gap and put another pile of color over on this side. So let's do blue and green on this side. The nice thing is these colors sometimes don't show up like the same color when they're all concentrated. Red. And the reason why I did the little space in between my piles this time is our swab has two ends. So if we put a little soap on one end, squeegee it out, get our soap on the other side, and now what I'm going to do, instead of just holding it in there, I'm just going to drop it in so that we get stuff on both sides, and now we basically have two fireworks going off at the same time. Cool. Fun with color, fun with color. So what did you think? Kind of fun to do some fake fireworks in the house, wasn't it? Anyway, hope you enjoyed that. Give it a try at home if you can. And also check out some other videos on our Science at Home page at 3m.com. Thanks.